This video shows a method called elimination through subtraction, which is being used here to find the equation of a linear function when we have points in a table of values to work with. What I'm going to do is I'm going to use the y equals mx plus b form, or y equals ax plus b, as it's also referred to. I'm going to write two versions of this equation in this form, and I'm going to substitute for x and y coordinate pairs that are from my table of values. So I'm going to start with this middle point, 24 equals m times 3 plus b, and using this first point, 8 equals m times 1 plus b. I'll rewrite those expressing this term in a more usual way. 24 equals 3m plus b, and 8 equals 1m plus b. I'll just write 8 equals m plus b. And then what I do is I subtract the second equation from the first. 24 minus 8 is 16. 3m minus m is 2m, and b minus b cancels. So 16 equals 2m. We can find our m by using algebra to isolate it, and I get m equals 8. I know that my equation will be y equals 8x plus something. I need to know what the b is. To find that, I'm going to substitute another point from the table, again, into this version of the equation. I'm going to use this last point, x is 5, y is 40, and I get 40 equals 8 times 5 plus b, which means 40 equals 40 plus b. 40 minus 40 equals b. 0 equals b. My b is 0, my y-intercept is the origin. My final answer for the equation of this line will be y equals 8x. Or if you wish, y equals 8x plus 0. Let's do it again with this second table of values. I'll go a little bit faster this time. I'm going to use the last 2 points. So I have 46 equals 7m plus b, and 41 equals 6m plus b, subtracting 5 equals m, and the b's cancel. So I have my slope is 5. I know the equation will be y equals 5x plus something. I need to know what my b is. But this time, in the table of values, I was given the y-intercept. I know that b is equal to 10, so therefore I don't have to do this step. I can write my equation as y equals 5x plus 10. Now this set of data is not exact. This is experimental data, which doesn't always give us perfect values. And when I did my constant difference trick, I was getting slightly different answers. But I was justified in saying this is very close to giving me a constant difference. It looks like a constant difference of 10. But I'm able to find an equation the way I did. I get slightly different answers depending on which points from the table I choose, but all of the equations that I would arrive at are going to be very close to this, and this equation is meant to be an approximation of the equation that describes the linear relationship reflected in this table of values. This is elimination through subtraction.